You mentioned, when I showed you that before, you mentioned I did not cover the sun survey point, and then you mentioned as I was talking that I just looked up local noon there, and maybe that was wrong, I think. So why don't you take the next segment and tell me what I need to know about that sun survey point. And if you need me to share, can you share?
I don't know. I don't know if I can.
All right. I don't know if you can see, I'm showing the sun survey point number one, sun survey point SSP.
Okay, so here's a real important one. We talk about the sun survey point, when we have to understand that this comes from military science. In other words, in artillery, we use celestial bodies to in place survey. They call that a hasty survey, hasty astro survey. So in other words, when I want to put a howitzer or a firing battery, there are 6 to 8 guns in a battery. When I want to put them on common direction, in other words, I want to put them towards the enemy, I need to orient them. How do I orient them? At nighttime, I can use the stars. I've used Polaris. I like using Polaris because it doesn't move. In the daytime, we can use the sun. So what I do is I put in my own survey. A lot of times I put in using the sun. So when I do that, that comes from the exact observer location. In other words, I can't just use a city and say, I'm going to use timing. Kabul is 30 miles across. So if you go by timing in 30 miles, not accurate. Okay. That's why
cool.
I use the Marx device. So the Marx device is a very manual device, and it was created by myself. Initially, I did it with tripods. I had 2 tripods and I had a string. And what I was doing is I was going up underneath the string trying to get 90 degrees and looking up at the sun. Now that's hard. And I'm like, okay, this isn't working too well. I need to simplify this. Right methodology, right idea, wrong equipment. So I need to get this closer to the surface of the earth so I can be more accurate. And when I did that, when I created, and I talked to a Latvian, I was on a special operations base. I said, hey, because he came over and asked me what I was doing. I said, I'm measuring sun height, see if the earth is flat or it's a curved surface. And he goes, that's interesting. He goes, well, what does it matter? And I said, well, let me ask you this. I said, if you're having a bad day and you and your wife are always arguing, I said, you're still going to have a bad day whether the earth is flat or it's curved. Okay. It doesn't matter. Okay.
Yeah.
But I said, if somebody's getting billions of dollars getting paid billions of dollars to tell you something you don't actually live on, it might be a little bit of a problem with that. And he looked at me and goes, yeah, you're right. He goes, I've got a workshop. Let's go make this device. So I said, all right. And his name was First Sergeant Marx. He was a Latvian First Sergeant Special Forces soldier. So off we went to make the Marx device. And that's very simple. And that's the Marx device. All it is a simple, it's a piece of wood about 6 by 2 foot long, 6 inches wide by 2 foot. You put 2 screws or nails in, and you suspend a string, and you put a hole in the center. And the idea is, or the concept is that sun, you orient that device using a compass north and south. And that is what we call the line of, and you'll hear it, the line of magnetics. So you want to orient this north and south. So you're creating a grid line as the sun intersects that. It's going to create that shadow. So what you want to do then down below, you can see where that sun is center line to that shadow. Okay. That's how we get our exact timing, the exact location. Now, can we adjust our time? All we got to do is move the device, okay, to the sun position. Because let's say, Matt, you're out in California, right?
Mm-hmm.
So where you're exactly living, you may not be able to get exact noon. You might be able to get from 12:45 to 13:20 in the afternoon. That might be where the sun intersects you the best. So you may not always be able to get noon where you're at, okay, at noontime. So it's based on the observer location. That time is flexible.
Okay.
However, once you set that time, and we'll just use noon, that starts your clock. So if you start your clock at noon, when that intersects that shadow of center line that board, because what you do is you put a mark in the ground, a stake, or I use a bottle cap. That's my survey point. All right. And remember, I've got that oriented, that Marx device is oriented north and south, okay, by a compass. Why do I use grid, or why do I use magnetic north? Why do you think?
I don't know. I would think you need to include your declination, but you didn't.
You don't really need to. And here's why. It's a reference. It's a reference point. It's a start point. In other words, I'm now making this process accountable. And that's another issue I had with the heliocentrism and heliocentric model, lack of accountability in a lot of their processes. In other words, we should have been taught how to determine whether the Earth is a globe or it's flat in grades 6 through 8. It should have been a step-by-step process. Oh, Johnny, Susie, we're going to do this experiment step by step. Here's why you live on a globe. Didn't happen. As far as I know, I've talked to people. I can't find anybody that says, well, my science teacher.
We did.
Okay.
That's one of the things, by the way, that's one of the things I've talked about with other people on the streams. We have very different science educations. Right?
Yeah.
It's
I put that in my top points.
It's not a level playing field.
Yeah.
So
Yeah.
we did some experiments when I was a kid, but I know that it was very special. I went to a special school, right?
Oh, okay.
We
Cool.
did that stuff.
I'd be interested in hearing that. But going back to the board, the Marx device. So what the Marx device is, and the reason that you use magnetic north, and you can declinate if you want. You don't have to, because it's a line of reference. Now you're creating accountability within that process. And on that line, you're going to put a dot, and that's your survey point. So now that's where you're going to take your sun angle measurements from when you set up your orienting station over that survey point. That gives you exact timing. So when I see all these charts come out, we go, well, your time is wrong. I don't remember seeing you at the survey point with a clock. Okay. That
Right.
doesn't work like that. This is how timing works. This is the same thing that the military science people do in artillery. Same thing. This is just a lot more manual. Okay. So you're learning the very manual how to get correct. This is correct timing at the sun survey point. And that starts your clock. That starts your 24-hour clock. Now, how do we know that this is accurate? In other words, when I take this process and I say, well, how do I know that timing is accurate? Guess where Mr. Sun shows up 24 hours later? About 4 inches from the survey point. That's how we know that that is accurate. So in other words, if I look at my distance, and there I was from my other point, the 12-hour mark and the 11:38 mark, when I did what I talked about, the tripods, that was the difference. That's how far I was off. So this delineates, an exact point on the Earth, where the OS is coming, where you're going to measure from.
Okay, let me see if I understood.
Mm-hmm.
You got a string that is lined up directly over the top of that hole.
Mm-hmm.
So when the sun casts a shadow of the string right down the middle of the hole, that's when you know the sun is aligned exactly with the string.
That is correct. And now you have what? What do you have?
You would have local noon.
No.
If you were properly aligned north-south.
What do you have?
Because you are actually aligned magnetic north, you're very close to local noon now.
What do you have?
I don't know. You have the local noon time.
You have Earth to sun to observer alignment.
Right. That's what we call local noon.
That's key. So now,
okay,
you may call it local solar noon, but now you have correct alignment. So in other words, if I asked somebody, and I've asked heliocentrics, well, how do you get your alignment? Don't know. In other words, I'm going to point to a point on the ground. Give me alignment to that point.
What do you mean? Give me alignment. So that doesn't mean anything by itself. You need more
Well,
work.
it certainly does. If I give you a point on the ground, I said, get me proper, correct alignment to that point on the ground with the sun and you as the observer, so where I can take angled measurements or I can measure sunlight.
Oh, okay. You may get stumbly answers on that because the vocab you're using is not standard vocabulary.
Yeah.
So I don't know what you're talking about. But because we've been talking and I've heard your explanation, now I understand what you mean. You mean I want to align this thing so that the sun and the string and the dot are in a straight line.
Right. Correct.
Yeah.
Basically, that's correct.
Great.
Why is that important?
I would say we normally do it with shadows.
That's where I'm going to take my measurement. That's where I'm going to take my measurements. So in other words, it's no longer ambiguous. So
that's cool.
It's not an ambiguous, because people say, well, and I've seen this in the flat earth community, say, well, you can measure sun angle, but yeah, where's your point on the ground? In other words, it's an ambiguous measurement. Now this creates accountability. Okay.
What I always do is I leave my point still
and
I let the shadow move across. And then at the moment the shadow crosses either straight north-south or else when it's the longest it possibly could be, that's when you know you're in alignment.
All right. So now you can start once you have that, then you can start your clock. So you put your spot on the ground.
So you started your clock using that.
Exactly. Cool. So now our first reading, if our sun is at that position, is going to be a westerly read. So in other words, we're going to get a westerly read. That's going to be our first reading at west. Right. So when we look at that, so that's basically how you're basically setting I call it setting the geometric edge.
Okay. Very cool. Yeah, I totally understand that. If anyone's in the chat, ask us if you don't understand. I don't see anybody, but we'll keep going.
Okay. Does that kind of make sense to you?
Oh, absolutely. Absolutely. Let me say it back in my own words. You could just look up local noon for Kabul, but that would be for the whole city of Kabul, not where you're specifically at. And maybe it wouldn't even be correct. So what we're going to do is with this device, you're going to use the shadow of the string to establish exactly where local noon is at that spot when the sun is at its highest, when it is right there. And then you're going to time off 3 hours later from there.
Right. And I think it's important too is, because some people may get confused and say, well, does that mean the sun's straight overhead? No, the sun is going to intersect, because if you're up in the north, so the sun is going to come across that from the south.
Right. So it's not going to be straight overhead. It's going to be the highest point during that day, which will be something less than 90 degrees.
Exactly.
All right, cool. Is that wrapped up on the sun survey point?
I think so. I think we're pretty clear on that.
Okay, very good.